welcome to the core interview with Dr. Addy, and today we'll be discussing mainly undergraduate opportunities for students that are either aspiring undergraduate students or already doing their undergraduate student and want to know what is out there in the field for them. So before we get started, a quick introduction to Dr. Addy. So Dr. Heather Addy is currently working at the University of Calgary as the Associate Head of the Department of Biological Sciences for undergraduate students, and she is also a teaching professor. So some of the courses she's teaching this semester is Biology 435, Fungi. It's an amazing course, and if you're in biology, you should definitely check it out. I'm having a blast learning about fungi right now. And so she did her Bachelor of Science and Master's at the University of Alberta, and then she did her PhD at the University of Guelph. And so, Dr. Addy, you want to maybe expand a little bit on that and maybe introduce yourself a little bit more? That'd be really great.
Sure. So as Ali mentioned, I did my undergraduate, my BSc at the University of Alberta. I finished that in 1983, which seems like a very long time ago. And that was in botany, which is what we were calling the plant biology area of study at that time. And I went right into a master's degree looking at sort of reclamation-related issues in the foothills of Alberta, looking mostly at coal mine land. And that got me really interested in interactions between plants and fungi. And I spent a little bit of time working for both the University of Alberta and for the provincial government, looking at those sorts of topics, sort of plant reclamation and interactions with fungi, and decided to go on and do a PhD, which I did at the University of Guelph in 1995. And I joined the University of Calgary in 1998. And I guess it's been 22 years. Mostly I focus on teaching, but I am also currently the associate head for undergraduate programs. And it's that context that's probably the most helpful in talking about how you get involved in research in our department.
So I wanted to ask you how COVID has affected, you as a professor, how it's affected your teaching and how you design your classes.
So it has been really challenging as a professor, as I'm sure it is for students as well. But in my teaching, because I use a collaborative learning approach, our classes together and the labs are usually dedicated to students working in teams to solve problems or work on assignments. And I do some lecturing, but most of the time together is spent with the students working in groups and me circulating and helping them as they work on assignments. So there's a lot of time talking to students and getting to know the students and working with the students. And now that is all gone. And I'm finding it really, really challenging to feel connected with students when they're just little faces in boxes now and then on the screen. And it's very hard to get a sense of what they're understanding and what's not clear when you're not there with them, or when I'm not with you, I guess, because I'm talking to a bunch of students. I think the biggest thing I've heard from students is how hard it is for them too. I mean, none of us signed up to teach and learn online. It's not like you chose to go to a distance sort of university. So it's not something any of us is used to, and everything takes a lot longer. And the workload is the main thing I'm hearing from students, that the workload feels quite overwhelming a lot of the time, because we've all tried to do things like, oh, maybe I won't have one great big midterm and one great big final. I'll have several small assignments. But if we're all doing that, then students are juggling many, many assignments each week. So I think that's the main thing I've heard, and the main thing I'm thinking about for my course next term is how do I avoid some of these problems?
Further on, what tips would you have for future undergraduate students or current students that maybe plan to go on in this field?
Right. So I think for online school, the main thing I think is important is to structure your time and try and come up with your own deadlines and structure for your day. Because the other thing I'm hearing from students is if you don't have any synchronous classes, or not as many as you did, sometimes, everybody's posting their lecture videos and recording them, but then you've got 3 hours of videos that you are supposed to watch at some point, and it's really hard to feel motivated to do that. So trying to set yourself some time every day to work on a course, and that's a good thing to do if you're in person as well. So one of the things that works for me is It's an approach called the Pomodoro technique. And Pomodoro is Italian for tomato. And its name comes from those little kitchen timers that look like tomatoes. And what you do is you set a timer so that you're working on something for 25 minutes, not interrupting. And I find that really helps when you're thinking about, oh, I have to do this, and then, I have to do that too, and then there's that other thing. So you set the timer, and for 25 minutes, you just focus on one thing. And then you take a 2-minute break, and you set it for another 25 minutes and work on another task, or you could continue that one task. But the goal is to focus on one thing. And then after 2 25-minute sessions, you take a longer break, hopefully go outside, do some exercise, do something, and then you come back and you repeat that. And I find that really helps me get things accomplished, because 25 minutes is a fair chunk of time, but it's not so long that you get distracted or you sort of let your mind drift. So I think having a structure like that is a really important habit to develop for getting things done. The Taylor Institute at the University of Calgary has some resources for students and for professors about teaching and learning online. And they have some really good guidelines about how to approach an online course. So I would say take a look for those sorts of resources, because not every tip in there is going to work for everybody, but there's probably going to be a few things in there that'll work really well for you.
So most students that take an undergraduate degree in biology are looking for professional degrees like medicine, optometry, pharmacy, and most of these deal with human subjects or patients. Do you think that there are a lot of opportunities for students to deal with non-human organisms?
Yeah. So many of our graduates do end up pursuing something like veterinary medicine, which would be non-human organisms. We also have a lot of students that pursue working with microorganisms, so ending up working perhaps as a lab technician or a research associate working with microbes. So doing some courses in CMMB, for example, learning some of those skills in how to work safely with microorganisms is a really important skill that opens up a lot of doors for that kind of work. In terms of other areas, so plant biology would be another area where there's always a need for people that can identify native plants and know how to assess their abundance. So if you think about any kind of oil and gas work in Alberta, has to have an impact assessment done before the work can proceed. And part of that is going out and looking at what are the plant communities that are present there. So that's a real skill that students from our programs can develop. And there's lots of job opportunities in consulting if you have the skills in working with plants, for example.
And so continuing further down that line, then do you think you would need a master's or a PhD in order to get those positions, or do you think you can do that with an undergraduate degree?
So that's a really good question. It used to be the case for sure that an undergrad degree would open those doors for you. Certainly when I think back, I did some consulting work before I had my master's and between my master's and PhD. So it was possible at the time to get that kind of work. And I think there are some jobs you can still definitely get with an undergrad degree. So I have 2 students who were in my courses last year who are now both working for cannabis growing companies. They're both, well, one of them was a plant biology major. The other was not, I don't think, but had taken enough courses. And that's what he's doing now. It sounds like there's lots of opportunities within the company to move up and learn more skills in integrated pest management, for example. And so neither of them went further than a bachelor's degree and ended up with these jobs that do offer, I think, some good growth opportunities. But I think in many places in biology, a master's degree is a really good choice because it does open more doors. A PhD isn't required for most of these, and in some ways a PhD, I don't want to say it closes doors, but a PhD is usually taking you down a very specific path. You're either going to be teaching and doing research at a university, or you might be looking to be at a purely research institution. But a PhD is a much longer commitment, and it isn't something you need for a lot of these jobs. But I think a master's is always something to consider because it's actually a really fun opportunity. You get to focus for a couple years on something you're really, really interested in. You probably get to teach as a TA for part of that, which is always a great thing to explore, because maybe it'll open up. Maybe you think, hey, I want to go into teaching. So, I'd really encourage people to think about a master's as a next step, because it does open more doors.
My next question was, most students that are pursuing like a biology degree feel like it's a lot harder for them to find entry-level opportunities compared to students from other disciplines, say, for example, an engineering degree. Do you think this is the case right now for many students in biology?
So I think there's probably some truth to that. One of the things that I think is challenging is that we don't, in the biology department, we don't have a way to track what our alumni are doing. So if students contact us, so I've had these students that have gotten these jobs and they've been in touch to let me know that's what they're doing, then I know where they've gone and what's happened with them, but we don't have any other way to track them. The university as a whole can do that, but our department doesn't have that access. So I don't have data to back up all of this, but I think, if we're comparing ourselves to something like engineering or a business school, there are a lot of jobs out there that are sort of waiting for those people. And there are jobs in biology, but sometimes it's a matter of being sort of thinking laterally and looking for jobs that might not strike you as being directly related to your degree. And it's also partly, what's happening in the economy. So if oil and gas isn't doing so well, then some of these consulting jobs might not be as abundant. So I think it's maybe a little more challenging than if you're an engineer, but the jobs are out there. It's a matter of looking and making connections and thinking broadly about what you can do. Because even if you aren't finding a job that's exactly about biology, if you think about all the things you're hopefully gaining in your courses, things like communication skills, teamwork skills, problem-solving skills, those are all things that careers that employers are looking for.
Would you recommend students to go into a biology degree if they're not aiming for like a professional school like medicine or veterinary school or pharmacy, but looking to work in the field?
So I think the first thing I would say is I think students should pursue what they're interested in and passionate about, with the caveat of making sure that you're taking enough of a range of courses, because sometimes what you think you're passionate about ends up not really being the thing that really is exciting once you start taking classes. So often students come into university thinking they want to be a doctor, for example, because that's kind of what we know about science. You think, well, I'll be a doctor or a dentist or a teacher. You don't know about all the other possible jobs out there. So, I think thinking about what interests you, but allowing yourself to explore is what university should be about. So if biology is something that you love, or at least like, and you find really interesting, then I think a degree in biology is a good choice. And it will, hopefully, as you take the courses, you'll discover which aspects of biology are of most interest to you. And you should be able to develop a lot of the skills that employers are looking for.
What do you think are the most important skills that the student should be aiming to achieve in order to be competitive for these jobs?
So what we know from what employers have told us, not just at U of C, but across Canada and in North America, the key things that employers are looking for are teamwork skills, the ability to work well with a diverse group of other people. So that means things like listening skills and communication skills. So being able to speak clearly and to write clearly and communicate your ideas, but also to work with people that you don't necessarily like, but to be professional in working with them, and to work with people that you're very different from, and to be able to work towards a common goal despite all of those things. So having those professional interpersonal skills. The other thing we hear that employers are really looking for, we sort of touched on communication skills, they're looking for problem-solving skills, or you might call this critical thinking skills. So the ability to look at a situation or a problem and identify the components of that problem and identify how you might go about addressing it. So being able to look at a problem and structure your thinking to think about, what do I already know and what do I need to learn to help me solve this problem? So you've probably heard various professors talk about, we want you to be lifelong learners. And when you think about what being a lifelong learner means, it's not only being interested to keep learning, but to know how to learn something on your own. So that's skills like identifying what you know and what you don't know, and coming up with a plan for how you're going to learn it, or how you're going to organize your time, for example, and being able to self-assess your plan as you go, to look at your goals and say, how am I doing with reaching those goals? What do I need to do differently? What's going to help me keep on track? All of those things are skills that, you know, if you think about any course you're in, you can see for yourself probably where those skills come into play with, what's my goal for this course? Am I on track? You know, what do I need to do differently? Maybe my method of studying for this midterm isn't paying off quite well. What should I do differently for the final? So all of those things are skills that you can be developing in biology courses for sure. And one thing I did want to mention, because I didn't yet, are project courses in biological sciences. So what a lot of students don't know is that in biological sciences, we offer two kinds of research opportunities for students that are course-based. So there are courses called 507s, and there are courses called 528s. And these are offered within all of the specialty majors, so CMMB, BChem, ecology, plant biology, zoology. You can do either a one-term independent project course, which is called a 507, and those are often, they might be hands-on research, but they're often going to be like doing a review paper or doing a guided study with a professor, sort of a way to get your toes into the world of research. And those are open to all students, regardless of your major. There are some requirements for a GPA. You have to have a minimum GPA of 2.75 for the 507s, and you have to have completed a certain number of courses. So those are usually done by students in their third year. And then there are also 528s, which are full year independent research projects. And those really are intended to be hands-on research. So you're working in a lab with a professor or with a graduate student and designing and carrying out an independent research project. And again, those have a GPA requirement, and they're usually done in students' fourth year or fifth year, because some of our students stay for 5 years. But really think about doing those courses, because that's a great place to really develop and strengthen some of these skills in problem solving and in communication and in teamwork. Especially if you think about the 528, you're going to be in somebody's research lab working with their graduate students and their other personnel. So those are really great opportunities. And students sometimes don't know that they exist. So that's something to talk to either someone like me in our department, or the USC student advisors, or even senior level undergrads can be really important resources.
For those courses, what I understand is you need to reach out to a professor yourself and ask, what do you think is the best way for students to do that, especially if they are interested in a topic upon which, you know, they've never had this professor teach them before, or never interact with this person before?
Right. So I think a really good way to do that is by email. And the important thing when you send an email is to phrase it in a professional way, you know, address it to, you know, dear Dr. So-and-so. And it's important to do a little bit of homework to look at that person's research background. So if you go to our website, there's a link that'll show you research interests in the department, and it sort of shows you what everybody works on. And if you just take the time to read even just each person's website, you don't have to go read a bunch of their papers. But that way, when you're writing to them, they know that this isn't just a mass email that you're sending to everybody. So for example, if you were interested in working with Dr. Barkley, who some of you would know from Biology 313, you would write to him and you would make reference to the fact that you know that he works on bats, for example. And that you're really interested in bats, and make it genuine, so that the person you're writing to will know that you really are interested in working with them. and just say, I'm interested in your work on X. I would like to do a research project with you. When would be a good time to get together and meet? And it's really good to do that probably about now, this time of year, or early in the winter term, because by March and April, people will have committed to taking people into their labs for the following year. So the sooner you can do it, the better. And they might not know you because you might not have been in a class, but if you write a clear and professional email, you'll get a response. And that person might not themselves be able to take you into their lab, but they should be able to recommend someone else.
Well, Dr. Addy, thank you so much for doing this interview with me. It was a pleasure having you on, and I've learned a lot. Hopefully, the students can, or like the people that are watching this video, can take a lot away from this as well, and aspire to become our future scientists in biology.
That would be great. Thanks for inviting me, Elliot. It was a lot of fun.